I'm going to walk through the solution for Temperature Control Lab A for the Advanced Control section of the Dynamic Optimization course. We have the Temperature Control Lab here at this address, and if you just scroll down, you're going to see the assignments. And this first one is Temperature Control Lab A, Single Heater Modeling. And if you want to follow along with some of the source code, you can come down here and look at some of the solutions and the data files. So this link right at the top primarily focuses on the first principles modeling. And so you're welcome to view the videos and the source code for that. We're going to take a little bit different approach with this video, and we're going to go a little bit more into how to model this with a neural network. And this would be deep learning, where you have multiple hidden layers within your neural network. And we're going to be focusing on doing some of the modeling with deep learning. Okay, but we'll also cover just briefly how to do it with first principles. And the objective here is really to try to match to this data right here that we generated. And if you don't have a Temperature Control Lab device, you can still follow along. I'll have some sample data files that you can use. Okay, so the very first thing that we'll want to do, and we'll get this started first, is just generate some data from the Temperature Control Lab. And if you don't have that, I'll share with you a link. Okay, so we're going to generate a step test on the Arduino. We'll give it a file name. We'll come up with some heater steps. So I'm going to go from 10 seconds on, I'll go to 80% heater value, and then to 20. Okay, so this is what I'm doing to generate this plot right here, be able to collect the data. And then we're going to open the connection to the Arduino and open up a file and write the header. And then we'll go for 601 seconds. Okay, we'll set the heater value. We'll print just a line. We'll wait 1 second. We'll sleep for 1 second, and then we'll write the results to a file. And then we'll close that file each time through the iterations. So if you want to open up with a text editor, you'll be able to see it. And then we'll close the connection to the Arduino. As a final step, we'll read our data file and then plot the measurements. Okay, and then show it. All right, so that's our very first one. I'm going to go ahead and just get this started, just to start collecting some of the data. And so if you just open it up, I'll get this running, and maybe by the end we'll have some data. So it's going to open up a connection to the Temperature Control Lab, and then it will start collecting data for us. I'll just go ahead and minimize this as we're going through the rest of this. Okay, so the very first thing that we're going to do is just do our energy balance, and it's this equation down here at the bottom. And let's just walk through this together, how to set up and solve it. There are some of the parameters that you can use to solve this energy balance. I'm going to go through a little bit more quickly, just because there's already solution videos on this. We're going to initialize our gecko model. We'll select the number of time points, 601 in this case. We'll go 1 second each, so we'll do a linearly spaced values. And then we'll come up with our parameters. Those are the same ones that we're testing right now on our Arduino. And then we're going to come up with all of our parameters. Okay, let me move this over just a little bit because I have a little bit of word wrap going on there. Okay, so I come up with all of my parameters as listed in that table. And then I have my variable, which is the temperature. And then I have my equation. And so there you can see this is the energy balance that you see down here at the bottom with my convection, radiation, and then the inlet heater term. I do alpha times T because that relates percent heater to the actual number of watts. Okay, and then I simulate it, and then I'll solve it, and then let's plot it. Okay, so once this is done, I can go ahead and just run this. And if I go over to energy balance, okay, and then I'll run it, and then I'll see a result on what I should expect from running this. Okay, this is the simulation right here, and let me just come back over here to what the data is. So you can see there's the actual data, and there's our energy balance. Maybe let's put these two on the same plot just so we can see them side by side. You can see the general shape matches, but maybe not the peak. So let's just modify this script briefly to be able to incorporate the data that we're going to be collecting. And you can just go ahead and do right here, we're just going to import pandas as PD, and then I'll say data equals PD dot CSV read, and okay, and then I'll put in let's go back to the web address here. I'm going to come here to this address. I'll go ahead and get the dynamic data. Here's some that I just generated. You don't have to use this one, you can generate your own. But I'm just going to go ahead and copy that link right there, and I'll read that in. Okay, and then I'll plot it together with the model predictions here. And I'll plot data with time, and then also data with okay, and then I'll do, I think it's T1 in there, and let's make this a blue dashed line. Okay, I'll run it one more time, and it'll go out and just get that data and then plot it with my predicted values. Okay, and it'll run the gecko model, and it is not CSV read, it is going to be read, I think CSV. Probably got that wrong. Okay, let me try it one more time, and we'll just see if it how well it matches. Okay, so I'm just using pandas to pull in the data file, and there I can see, it's a little bit low. Maybe my ambient temperature where I was doing the test was just a little bit lower than my model prediction, and so I might be able to update that. Maybe instead of something like 23, maybe it was 17 degrees. Okay, and so I can update my first principles model and maybe run it again. Okay, so that's how we do the first principles modeling. It requires that you have some sort of fundamental knowledge about your system. Okay, and so you can see we're getting a little bit closer. Maybe my ambient temperature was off. Okay, so that is it for the first principles model. Okay, let's go on to the next approach, is where we're going to be using machine learning to do this, and in this case we'll be using deep learning. If you need an overview of how neural networks work, I would recommend playground.tensorflow.org, and this is a nice visualization of how to construct neural networks. Maybe you have a different number of neurons, you have different activation functions, and you're going to be doing a regression. Okay, so I'm going to fit that, and you can see this is the loss function, or the loss, and that's our objective function we're trying to minimize. And so you can see it's very near 0 right here, and we had these individual neurons with these weights that connect them to produce this final prediction. Okay, we're going to do the same thing, but in this case we're going to do it with Gecko, Python Gecko, to do our fitting, to create this this neural network. And we're going to actually do it in 2 steps here. We're going to first of all fit steady state temperatures, so between the heater value and the temperature at steady state, and then we'll pass it through one more block that's our dynamic block that relates the steady state temperature to the dynamic temperature. Okay, so here in the neural network script, we're going to go ahead and import some of our same packages, and here we have where we're going to import or generate the data. And so as we import or generate the data, it's going to first of all try to just read the file if it's there. If we don't have the file on our computer, it will go out and get it from the URL that I showed you, and we're just going to read that. And if that isn't there, if you for example, if you want to generate it yourself, you can do that with this script. This one is similar to the one that I just showed, but it just waits 3 minutes between each collection period and to write our file. Okay, so it doesn't do it every second. This one will take about 2 hours to run if you run this section of the code right here. Okay, that's if you want to generate your own steady state data. Okay, and then we want to scale that steady state data. We're going to make this just a little bit larger so you can see it. Okay, we're just going to import our heater and our temperature value, and then we'll find the minimum of those. So it's important as a first step to scale all of your values between 0 and 1 for neural network fitting. Okay, we're going to then do we have our range and our minimum, and so we're just going to scale the data. So XS and YS, those are going to be between 0 and 1 because we divided by the range and we subtracted the minimum. Okay, now we want to build the neural network model, and this is going to be with Gecko. There's our number of inputs, number of hidden layers. We only have one neuron for each of those, but you can change that. You can change this to 2, 3, 2 if you wanted to, and then it'll automatically update the size. Okay, but we're going to initialize the Gecko model, and we'll do a train and a test and then a dynamic simulation here, and we'll declare all 3 of those models as a list, and then we'll loop through all of those models and define them. Okay, so we're going to create 3 separate instances of our model. There's our input, which is going to be a parameter. That's going to be our heater value. Here's our layer 1. These are the weights between the different neurons, and then I have basically the outputs of those of those neurons. Okay, which is going to be L1. And so I defined an intermediate variable for the range of L1, which is in N1, which is just going to be 1. So that's just going to be one value that's output. And then I have layer 2. Okay, the same kind of thing. In this case, I have 2 list comprehensions here for J in range N1 and for I in range N2. So I'm just looping through those. That's going to be a matrix of outputs. And then I have layer 3 as well. And that layer 2 is a hyperbolic tangent, and then layer 1 and layer 3 are linear layers. Okay, oh, it just finished. You know what? And that, it looks like my heater value was not plugged in on that. So something happened here. Okay, it just popped up. Let me just make sure this is working. Okay, I'll go ahead and unplug my Arduino and plug it back in. Let me generate that one more time, and we'll see if we can get the heater to actually do something here. Okay, so the heater was not, looked like the temperature was not changing. Okay. Alright, so what I'm going to do now is go ahead and okay, so I'm going to pause it just really quick. Okay, I got my heater back on. I realized what was happening there, and so let me go ahead and just run this. Okay, so the heater is on. I'll go ahead and restart this just one more time. I just didn't have it plugged in, so that's why the temperature didn't increase. Okay, so there it's going to go again, and hopefully my heater will be on and we'll get some data hopefully by the end of this. Okay, so let me go back here. Here's an output, and I have my just one output, which is going to be a temperature, and then I'll flatten my matrices, my W1 through W3. Those are my weights. Okay, and you'll see why in just a second. I'll fit my parameters. I'm going to switch models from the this first one that I had, which was the training model. Okay, training model, I'll have a test, and then I'll have a dynamic simulation as well. So I'll go through each of those. I'm going to first of all just select my training model. Okay, my input is going to be these scaled values that we discussed before. We have the outputs that are going to be the scaled values as well. And then we're going to turn on the feedback status to say we're going to use that measurement. Okay, and then we're going to say that we're going to turn on the feedback status for W1 and turn on its status. So say tell the solver to estimate, to adjust that value, and give it an initial value of a measurement of 1. We'll do the same thing for W2. Just loop through all of those parameters and say that our measurement is going to be 0.5. That just gives us an initial weight. And do the same thing for the W3 parameter. Okay, we have I mode 2, which is a steady state estimation mode, and then we're going to use the IPOpt solver, and we'll set it as a sum of squared errors. So we're going to minimize the sum of squared errors between our predicted and our measured temperatures, and then we'll solve it. Okay, now we're going to test our sample points. So now we're going to switch our model over to the test model, and we want to load in all of the parameters that we just fit. Okay, so we're going to grab the new values of W1 and then insert those as measured values for our next model, our test model. I'll do that for W2 and W3 as well. Okay, and then I have my inputs. I'm going to just test it between -1 and 1.5. We only had the data that went between 0 and 1, so we're going to be extrapolating just a little bit here. Okay, and then we have I mode 2, which is going to be again steady state estimation, although none of my statuses are on for my parameters, so it should be 0 degrees of freedom. I'll solve it, then I'll unscale the predictions. Okay, there are my predictions, and I just needed to get those back into, percent heater and degrees Celsius. Before it was just scaled to 0 to 1, and then I'll plot the results. Okay, so I'm going to plot steady state, this plot of my predictions, and these are going to be my steady state predictions. Now I'll go on to dynamic predictions as well. Okay, so I'm going to run for 10 minutes, just like I did on the this energy balance one. Okay, I'm going to load my parameters in there. I'll do my doublet test, just like I did on the energy balance. And then I'll have my parameter, which is going to be the Q value, and I'll have to unscale that one, or scale it going into the neural network input. And then I'll also have this is going to be my output. Okay, I have a variable there. I have my parameter tau. Now in a later lab we'll estimate this, but just for in this case just assume 120. Okay, I'll have my dynamic model here, which is just going to be my temperature. This is a linear correlation between my temperature steady state and my dynamic temperature, which is T. Okay, I'll solve the dynamic simulation with I mode 4, and then I'll plot the results here. Okay, and then I'll show the solution. Alright, so this is my neural network, and let me go ahead and just run this one. Okay, and it will go through and estimate the relationship between the heater value and the steady state. Okay, so just fit that, and then here is my temperature. Okay, let me see how well it did with fitting the steady state values. Here you can see the neural network prediction for steady state temperature versus the heater value. You can see when you went up it was just a little bit colder. When you went down it was a little bit warmer. May not have been quite right at steady state, but it estimated something right in between them. Okay, and then if I wanted to put my predictions back in there, similar to what I did with the energy balance, I could do that. I could just read the data file in like we had before. And let me open this up. So we can compare how the neural network is going to do to our data. And if you're generating this, just go ahead and insert your own data here. Okay, and then we'll just plot again data time, and then data, and this one's just going to be T1. Okay, so let me make sure I have pandas imported here as well. Okay, it's right there. So we're ready to go on this one. I'll go ahead and run it one more time. Just put the data on there as well, just to see how well the neural network did in relationship to the data. Okay, so it's a bit off there. I think I may have used different steady state data to do the predictions. So we'll have to see with this new data coming in. I'd recommend using your own lab and generating the data and running these three. Okay, so I'm going to go back just here to the scripts here. You can see here is how to generate the data. Here's the energy balance code that you'll see here. And then the final one is the Gecko neural network solution. You can use any of those source codes and then modify it. I would recommend, if you're going to use any of these, that you always just use this get code link right there, and it'll give you the raw output instead of just selecting the code yourself. Okay, so there is the solution to Temperature Control Lab A. You have some of this data and these scripts that you can use. If you want to use MATLAB instead, that's fine. Just select this link right at the top, and there's some additional ones in MATLAB. I don't have the neural network example code for MATLAB, but here is a solution, a potential solution for you.